Radiation can also be used to monitor the thickness of things that we're manufacturing. So for instance, in this case we have paper, but it could be aluminium foil, and the more common example is aluminium foil, so we'll probably talk about that one. Or it could even be thick sheets of steel. But you basically pass the material through these rulers. They press down with a particular force on the material as it gets pulled through this way. And the more they push down, the thinner the material will be at the end of the manufacturing process. So what we do is we set a little radiation source, and we're going to pretend this is aluminium. So I'll change this to aluminium foil. And what we do is we have a little beta source, and it sends our beta particles through the material to this little detector, our Geiger-Müller tube. And let's say when it's exactly the right thickness, we have an activity of, let's just make a nice round number, 1000 becquerels. And while it's detecting 1000 becquerels, everything's good in the world, okay? The machinery's happy. However, let's say a fault occurs and this drops down to 800 becquerels. So we've got a smaller reading than the 1000 that we want. Okay. Now, the reason for that is not enough radiation, not enough of those beta particles are getting through. What could cause that? Well, the aluminium must be too thick. So if the activity drops, the machinery knows that the material is too thick, and what it does is it just moves these rulers closer together, produces a bigger force between them to make it thinner again. Likewise, the opposite is true. If this, say, went up to 1200 becquerels, well, we expect it to be 1000. Too much radiation is getting through. Why? The aluminium's too thin. Therefore, what we do is we just move these rulers slightly further apart. And that allows us to control how thick the material is without having to stop it and take measurements and then go and manually adjust those rulers. It's a much, much faster, more efficient process. Now, in most textbooks, we would talk about aluminium foil. But like I say, this works for paper and thicker material as well, but we have to be very careful about what source we select. So for aluminium foil, we would use beta, because if we used alpha, the reading down here would constantly be 0. None of it would pass through the aluminium. If we use gamma, then it might be 3000 becquerels, no matter how thick we make that aluminium foil, because it's not going to have much impact because gamma is so penetrating. Therefore, we need to use beta so that when it's thin, lots gets through, and when it's too thick, not as much gets through. If we were doing this with paper, we'd have to use alpha instead for the same reason. If I was manufacturing steel plates that are, say, 5 centimeters thick, then that would absorb all of alpha, all of beta. Therefore, we'd need to use gamma in that situation. Okay, so while in this video we mainly talked about aluminium foil and beta radiation, it will change depending on what it is we're manufacturing. So do make sure that you read questions carefully in exams to select the correct one. So we're saying this is aluminium foil, which means we would use beta in this case.